Okay, I'm going to put this PowerPoints in views later on at the end of the class or maybe tomorrow morning. Okay, so week 1 is basic concepts. We are going to learn about 3 main things in electrical. We are going to learn about the current, voltage, and the resistance. So when we connect a bulb to a battery, we know that electron starts to move when there is a closed circuit. So electrons are moving in this direction. So electrons are the ones which are moving. However, the conventional current is the opposite direction to the electron flow. So you can see conventional current, which is what we are going to use. So hereafter, we use the abbreviation I for the current, and it is starting from the positive side of a battery, and it is moving, and it will be lighting up the bulb, and then it is going back to the negative side. So it is a closed path. So we are going to learn what do we mean by the current, what do we mean by the resistance, and what do we mean by a voltage. So these are the simple and the basics of electrical engineering. So here we need to know what do we mean by the electron current and what do we mean by the conventional current. So conventional current is always starting from the positive side of the voltage source. So voltage source can be a battery, DC voltage source like a battery, or else it can be an AC voltage source as well. So as I have mentioned, the main 3 things that we are going to learn today are the voltage, resistance, and the current. If you look at the current is the rate of flow of the charges. So we know electrons are moving. So how fast these electrons are moving, that we call the current. So that means Q, we use the Q for the charge, T for the time. So how fast, Q divided by T gives us the current. So Q is measured in coulombs. The units for the Q is coulombs, and time is measured in seconds, and the current we use the amps. So these units are very important because otherwise you will lose marks even though you have the right answer. So current is equals to charges divided by the time. So we can do a small example. I would like you to try this one by yourself, and then I will explain you. I'm starting with the very basic simple things, but we can't expect the same basic simple things throughout the 10 weeks. So can you please try this question? Then I will do it and see whether you have understood what is current. So we have a 5 amp of a current, and they are asking us to find how many electrons are passing in 1 minute. So time is given to you, current is given to you, and they have given the charge of 1 electron as well. So this is the charge of 1 electron. So they are asking the number of electrons. So if you haven't understood the question, will you be able to find me at least the charge, total charge? We know current is equals to Q over T. So if you find the Q, will you be able to find me the Q, please? So can I say 1 minute as just 1, or should I make it to seconds?
It'd be seconds.
Yes. So always we need to have the same unit. So time should be in seconds, charge should be in coulombs, and current is in amps, SI units. So this many coulombs. So this many coulombs is for all the electrons which are flowing for 1 minute. So if you want to find the number of electrons, you need to divide this 300 total coulombs by the charge of 1 electron. Do you agree with that? So you will get the number of electrons flowing per minute through this circuit. So did you get the same answer as me? This many electrons in a minute?
Yep.
Okay, that's good. Okay, when we look at the current Current can be direct current or else alternating current. So at the very beginning, we are starting with this direct current. But I think in week 7, we are doing the alternating current AC systems, and we will be using calculus, and we will be actually we are using complex numbers as well. So that's why I told you at the beginning, you may feel like this is very simple. Even the year 7 person can do this. But I started with the simple stuff. We are going to more complex stuff at the end. So please take this one as serious, because at the beginning everyone think that this is easy, and I don't want any of you to fail this. So direct current or direct, like DC, stand for um, direct current, which is your current is not changing with the time. So it is the direction and also the magnitude. So you can see, even if I have a current like this is not DC, this is AC, not because of the magnitude. It is having the same magnitude, but it is changing the direction. So this is not a DC current. So DC current is always where you have the magnitude and also the direction in the same, which is not changing with the time. So alternating means it can be, this one is a sinusoidal current. It can be any shape, but if it is changing with the time, it can be the magnitude or the direction. If it is changing with the time, we call that alternating current. We need both, because there are some equipments that uses direct current to operate, and also alternating current is very important for us to get the current from the power plant to our household. So if we transport the direct current, that is a huge loss. So what we do is we transport the current as alternating current, and then we are going to learn this equipments as well. So we convert this alternating to direct current, and we are using them for our equipments which are running with DC current. So we need to learn both the direct and the alternating. So we are starting with the direct current, and we are moving to alternating later on. Then when we look at the voltage, we call that the potential difference as well. The energy required to move a unit charge, that we call the voltage. So voltage is energy divided by Q. So energy is measured in joules, and the charge is measured in coulombs. So energy divided by the charge will give us the voltage, which is measured in volts. Are we good? Any questions so far? No? I assume there are no questions. Voltage is always measured between 2 points. Current you can measure at a certain point. When you have your circuit, you can measure the current at a certain point, but when you are measuring the voltage, it is always in between 2 points, between a resistor, between any other, like, combination of resistors. So we measure the potential difference of the voltage between 2 points in a circuit. And then also we need to know the resistance. Resistance is the circuit element that dissipate electrical energy, usually as heat. So here you can see it can be resistance is equals to voltage divided by the current. We already know what is voltage. We already know what is the current. And the voltage divided by the current gives us the resistance. So resistance is measured in ohms. Voltage is measured in volts, and current is measured in amps. We already know that. So there are, when we look at a circuit, there are some elements which are supplying energy, and some elements which are consuming energy. So batteries, or else any motor, they are supplying generators, they are supplying energy. Motor, or else any electrical equipment, they are using energy. So there can be passive and active devices in a circuit. We will learn it later. So with this relationship, if you look at this one, resistance is equals to voltage divided by the current, and we can rearrange this equation and we can say voltage is equals to current times the resistance. This relationship, we call that the Ohm's law. So Ohm's law says voltage across the resistor is directly proportional to the current flowing through the resistor. So voltage is proportional to the current. So this proportional sign, we can get rid of that if we have resistance here. So V is equals to IR. This we call the Ohm's law. And there are two situations, extreme situations in a circuit. When the resistance is going to zero, that means there is no resistance. We call that short-circuited part. And when the resistance is going to infinite, that means it is open circuit. So that means the current can't flow through that point. So through that branch. So these are the two extreme cases. Otherwise, resistance can be any number between 0 and infinite. Okay, so let's see whether we have understood these three concepts. So we have a battery with 120 volts and connected across a resistor and causes a current of 6 milliamps to flow. Determine the resistance of the resistor. So we need to find the R. And then if the voltage is now reduced to 50 volts, what will be the new value of the current flowing? So you are now having the same resistance here and you need to find the current. Can I give you a few minutes for you to try this one? So voltage is equals to current times the resistance. So we need to find the resistance. If we make the resistance the subject, V over I. So voltage is given as 120 and the current is 6, but we can't keep the milli. So we need to convert it to amps. So that is 10 to the power negative 3. So you get something for the resistance in ohms. And in the next part, you have the voltage. So voltage is equals to current times the resistance, which is the same equation or the Ohm's law. And we need to find the current now. If I make the current the subject, it is voltage divided by the resistance. Voltage is 50 and the resistance is whatever you find here. You can put that one here and you get an answer in amps. What did you get? Did you get these two numbers? 20,000 ohms. And here you have 2.5 times 10 to the negative 3 amps. Are these values are right? Okay, so
Yep.
that's good. Anyone have any questions? No questions. Okay, now let's see power. Power is the rate of expending or absorbing energy. So there are some devices which supplying energy and there are some devices which consuming energy. So energy is, we say energy can't be neither created or destroyed. So energy should be transferred to another part. So here we have electrical energy, we can make it to mechanical, or else when we generate electricity, we convert mechanical energy to electrical energy. So energy, there are devices which consume energy and also there are devices which produces energy. So if that rate of expending energy or absorbing energy, that we call the power. So energy rate or energy divided by the time will give you the power. So if we say energy divided by the time, we know in the previous slides we discussed voltage is energy divided by Q and current is charge divided by the time. So energy divided by the charge and charge divided by the time is voltage and the current. So if I just times this one by Q and divided by Q, I'm not doing anything wrong because I'm dividing and multiplying by the same number. So we can rearrange this like this. So this will give you the voltage and this will give you the current. So we say power is equals to voltage times the current. Or else you can rearrange this one. Instead of having V, you can say IR here because Ohm's law say V is equals to IR. So instead of having V, you can put IR and you can say power is equals to I squared R. So there are three equations for power, which you can just rearranging and get it by yourself. Or else if you want to get rid of the current, you can say current is equals to voltage divided by the resistance. So you substitute that one here. And you can say power is equals to V times V over R, which is equals to V squared over R. So we have three equations for power. Power can be VI, power can be I squared R, and power can be V squared over R. So depending on what information you have, you can use any of these ones. So we started with the basic definition of power, and we have three equations now to work on the questions. Are we good? Any question? Okay. Okay, so if there are no questions, I want you to find the answer for this question, this example. What is the resistance? So you can use, we know V and R. We have to find R and we know the V. So we need to use this. Am I right? You don't need to remember equations. Equations will be given to you for the questions. However, they are basic things you need, like, it's better to get familiarized with this one. When you do more questions, you will get familiarized with these ones. So P is equals to V squared over R, and we need to find the R. So I'm making R the subject, so that is equals to V squared over P. So V is 120 squared divided by 25 watts. Power is measured in watts. I forgot to tell you that. So you can find the resistance in ohms. What do you get? Did you get this? The second part is not in the question, so you don't need to do this part. So did you get 576 ohms?
Yep.
Okay, that's good. Okay, now let's see. That's the basic stuff. Okay, now we are going to move to circuits. Circuits means we have a closed path. Current is flowing. So current to flow, there should be a closed path. Now, in a circuit, we need to know how to read the circuit, the terminologies that we are using when we describe a circuit. So circuit, we have branches. So branch represent a single element such as a voltage source or a resistor. So this is a branch. This one is a branch. So, and this is a branch, and this is a branch. Also, this is a branch. So there are 1, 2, 3, 4, 5 branches here. Do you agree with me? It's the same circuit. These two are the same circuits. They are wires. You don't have to keep them like this. They can be like, bended. So you can simplify. Normally you get this kind of circuits in questions, but you can imagine this version as well. If you are not okay with this. But when you do questions, you will be okay with this circuits. So branch is something with one element. Element means it can be a voltage source, it can be a current source, it can be a resistor. Later on, we will learn about the other elements like inductors, capacitors, diodes, what else? There are many other elements. So we will learn about those ones in the future. So for the time being, any single element path, we call that a branch. Node is the point of connection between two or more branches. So you can see here, this is a node. These are nodes. So nodes are the places where we connect branches. And loop can be a closed path, any closed path. So can you tell me how many loops are here? This is wrong. That's why I am asking. This is not, it's not only 3 loops in this one. Can you tell me how many loops we have? These two are correct, but the loops, number of loops, how many number of loops there? 1 loop, 2, 3. Are there any other loops? Can I say this as a loop? Is that right? With the definition, is it a closed path? Yes, so that is a loop. What else? This is again a loop. Agree? And this whole thing again a loop. So there are 6 loops. Agree? These ones are important for the future topics as well. When we consider mesh and loops are 2 different things. You need to understand what is, you need to understand what is loop to understand what is a mesh. So I hope you are okay with loops. Are we good?
Yep, understand.
That's good. Okay, now let's see the circuit elements. So we can have active elements. Active elements are supplying energy, and passive elements which are using consuming energy. So at the very beginning, we will look at, we don't look at all the active elements and the passive elements. However, we need to have that understanding. What do we mean by active and passive? So this is when you have something with a positive side and a negative side. This is a voltage source. So you have 2 voltage sources here. The difference between these two is one has a circle, the other one has a square or a diamond shape. So both are voltage sources. However, this circle is an independent source. That means it is not depending on a current or any other thing. It has a fixed value. But this diamond shape is a dependent source, dependent voltage source. The value of that dependent voltage source is depending on something. So we will do questions, then you will get familiarized with this one. And these elements here, which are arrow, those are the current sources. So again, current sources can be either independent or dependent. So whenever you have a circle, it is independent. Whenever you have a diamond shape, it is dependent. And these 4 elements are active elements which we supply energy. It is dissipating energy. It's not consuming energy. And passive elements can be, there are more passive elements. However, resistor is a passive element. It can be a radio, it can be a TV, it can be a light, computer, your mobile phone. When it is charging, again, it is consuming energy. So it can be any electrical device which is consuming energy. And also we can have inductors and capacitors as well. Inductors and capacitors, I will explain you when we come to that topic. They are passive elements when they are charging. They can store energy and they can supply energy. In that situation, when they are supplying energy, they are acting as active elements. So it has a charging situation and also discharging situation. So we will leave this for the future, but we are going to look at resistors and dependent and independent sources. Okay, now let's see how we can understand the differences between the dependent and independent. So we have two sources here. Are they voltage sources or the current sources? Are they voltage or current sources?
They're voltage.
They are voltage. Why we call them voltage? I told you, you always need to look at what you have. Whenever you have a positive and a negative side, that is voltage, and when you have an arrow, that is the current source. So current is arrow, voltage is a positive and negative. So they are voltage sources. So the diamond is dependent. So you don't have a fixed value. It is depending on a current. So it is 15 I2. I is a current. So when I is changing, this voltage is changing. But this one, the one at the bottom, is an independent voltage source. It has a fixed value of 10 volts. Whatever the current is, it is having the 10 volts. So if you know the current, you can find the dependent source's voltage, which is 15 times the current, 15 volts. So I told you voltage is always measured in between 2 points. So 10 means these two, this is a branch. Am I right? These 2 points represent a branch. At this branch, which you have one element, this voltage is 10 V. And if you consider this one with the 1 amp current, this is 15 volts. But if I ask you to find the voltage between this point and this point, that will be, you should know how to calculate it. It depends on your positive and negative sides, and we will learn it later on. But I just wanted to tell you that voltage is always measured between 2 points, and we can have the algebraic sum, and we can find this one if we know the voltages separately. And you can't just say, in this case, yes, it is 25 volts, but always we need to look at the signs, positive and negative sides of these elements to calculate it properly, and we will learn it later on. Okay, so I think you are now okay with the differences between dependent and independent. Okay, now let's look at the energy. So I told you some elements are supplying energy. So in this case, you can see this is a voltage source. Whenever you see like this is again a voltage source. It also has a positive side and a negative side. Before I told you this is a voltage source, but this is also a voltage source. This is for a battery. So when we have a battery, we have a symbol for a battery, which is this one. So this symbol also, you can consider it as a voltage source. So here they say 45 volt voltage is supplying by the battery, and that voltage is consuming, or else that energy produced by the battery is consuming by these 3 resistors. When you look at the energy conservation law, energy can't be created or destroyed. So whatever the energy supplied by this battery is using by these 3 resistors. Is that make sense? So if you want to find the energy or the power, if you consider the power P1 should be equals to the power consumed at P2, P3, and P4. If you say P1 should be equals to P2 plus P3 plus P4, because whatever the power generated by the battery is used by these resistors. However, there are losses in circuits. We are not going to learn into that depth in electrical fundamentals, but if you do electrical engineering, you will learn them later on. Are we good? Any question? Okay, now let's see. Resistors can be in different configurations. They can be in series or they can be in parallel. So series means they are staying like this. So it's in one, like inside a one loop. But parallel means they stay like this. So what are the differences between this parallel and series? What can you say? In the series situation, the current is going out from the voltage source. That current, the same current, is passing through all the resistors. When the current is the same, the resistors are in series. However, if you look at the voltage across this one, voltage across this one, and voltage across this one doesn't have to be the same. It can be different depending on the resistors. So if you want to find the voltage here, that will be the current times the resistance 1. The voltage here will be current times the resistance 2, and voltage here is the current times the resistance 3. So you can see, even though the current is the same, as the resistors are different, we can have same or different resistors, but we can't exactly say the voltage is the same. So when resistors are in series, we have the same current through every resistor, but the voltage can be different. But if you look at the parallel situation, the current is coming out from the battery, and when it goes to this node, it is splitting. So this current I is splitting I1, I2, and I3 like that. So you can see here in in parallel connection, you don't have the same current across every resistor. However, you have the same voltage. Do you agree with that? Voltage across these 2 points, this is a node and this is a node as well. So if you consider these 2 points, the voltage is the same as the voltage supplied by this voltage source. So whenever we have resistors in parallel, voltage is the same, but we have different currents. Do you guys okay with series and parallel connection? Any question? Okay, now we need to know how to simplify resistors in series and parallel. Simplification means when we have many resistors together, we should know how to combine and make it to a single resistor. So whenever we have resistors in series, you can add them together and we can make it to a single resistor just by adding the resistors like this. So if you add the 3 resistors, you will get the equivalent resistors. And you can just need to add them. And when the resistors are in parallel, you can't do that. Your equivalent resistance, 1 over the equivalent resistance is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the difference when you are adding and simplifying circuits. So we are going to use this in solving questions. So these equations are not given because these are basic concepts. So you need to remember how to add when the resistors are in series and when the resistors are in parallel. Okay, now most of our questions, we get 2 resistors in parallel. So when we have 2 resistors in parallel, we can use the same theory that we have learned, equivalent resistance. 1 over the equivalent resistance is 1 over R1 plus 1 over R2. So we can simplify it and we can remember it. We can save time if we can remember it. So if you simplify this, how do we simplify fractions? We get a common denominator, right? So if I times this one by R2 over R2 and this one by R1 over R1, we get a common denominator which is R1, R2. So we have R2 minus R1, 1 over R. Agree with this? And to find the R, we swap it upside down. So R is equals to R1, R2 divided by R1 plus R2. So you can remember this one. Whenever we have 2 resistors in parallel, we can times the 2 resistance and divide it by the sum. For example, if I have 5 ohms and 10 ohms in parallel like this, I can add them. We can say 5 times 10 divided by 5 plus 10, and we get the equivalent resistance. Are we good? Any question? Okay, if you don't have any questions, I want you to simplify this and make it to a single resistor, please. I'll give you a few minutes and I'll help you if you can't. So I want you to make this to this. And I want you to find this one for me, please. I'll give you a few minutes. Yeah, which ones are in the series or parallel? How do we recognize them? Are they in series or parallel?
There's 2 in series and the 2 6-ohm resistors are in parallel.
Okay, so these two are in parallel. That is right. So if you make it to a single resistor instead of having 2, how do you do that?
1 over the resistance
Yes.
over the total is equal to 1 6 plus 1 6.
Yes. So you can either say it like this. You can do this one. So if you do that one, what you do? 2 over 6. Am I right?
Yeah.
And you have to swap it. So you get 3 ohms. Am I right?
Yeah.
And also, if you can do this as well, as I have told you, without going all these steps, you can remember that equation I told you. So it is R1 times R2 divided by R1 plus R2. That means 6 times 6 divided by 6 plus 6, which is again 3. So you can do this way. There is nothing wrong. But if you want to remember this one, when you do few questions, you will eventually remember this. So this is 3 ohms. Anyone have any question to convert these two parallel resistors? They are parallel. Why is that? They have it's not having the same current. When the current coming out from this positive side, this current comes to this node and it is splitting. So if you have the same current across the resistors, I told you it is series. But here the current is splitting so that they are in parallel. So this two we can convert it to a single resistor. So that is equals to this. Do you agree? Anyone have any question? Now, what can you say about these 3 resistors? Are they in series, parallel, or what?
They're all in series.
They all are in series. So when they are in series, you can convert it to a single resistor just by adding the 3. So 3 plus 5 plus 3, which is equals to 11 ohms. So you can convert this to this. You don't get this kind of questions. This is most simple question. But if you understood this, you can go for a very complicated one as well. Just identify which ones are in parallel, which ones are in series. That's all. Are we good? Any question? No questions? Do you want to do more questions, or can I can take questions from the tutorial and can let you guys to try, or else I can finish all the theory today and we can do all the questions, mix of questions on Wednesday. How you want me to do? Complete one part and do questions on that part, or else do you want me to complete the theory today and do all the questions on Wednesday.
If I have my say, Yupika, I would just say keep going, and then we can work through the questions before we have our second tutorial.
Okay, so you also can try in that way before the class if you want to. Yeah, others are okay with that?
Yeah, that's fine.
Okay, so we'll do that way. Okay, so that part is just understanding the series and parallel resistors. Now there are two main laws that we are going to use. We are going to learn and we are going to use these two laws throughout the course. Kirchhoff current law and the Kirchhoff voltage law, very important. So far we have learned the Ohm's law, which says V is equals to IR. And now we are learning two laws, Kirchhoff laws. So we use the abbreviation KCL and KVL. KCL for current law, KVL for the voltage law. Let's see what are they. They're very easy, but if you don't understand it, you can easily get wrong in this one. So Kirchhoff current law says whatever the current coming into a node is equals to the current going out. So if you look at the node, we know what is a node. Node is a connection of branches. So here we have a node. So you can see there are few currents coming into the node. So you can see I1 is coming in. You look at the arrow, and I3 is coming in, and also I4 is coming in. So these three currents, whatever coming into this, should go out. So it should be going out currents are these two. So if you add the currents coming in, it should be equals to the currents going out. Does that make sense? Any question? So current law is that simple. Now let's look at the, okay, we'll do a question before that. What is the current I in the following circuits? So can you tell me? You want me to, I want you to find this one. Look at a node. You can use any node. This one or this one. You don't need this node actually because that's the same current across that node. So if you consider this node here, what are the currents coming into the node? Arrow towards the node. Just 8, am I right? So current in is equals to 8 amps. Agree? What are the currents going out? Arrow going out from the node 2 and I. So current out, the sum of the current out is 2 plus I. So Kirchhoff current law says whatever coming in should be equals to whatever going out. So 8 should be equals to 2 plus I. So I should be 6 amps. Are we good? Can you try the next one, please, and find me the I? You don't need to write a number. You can just in your mind, you can do it and tell me what is the answer.
3.
3 amps. How did you do that? So if you look at this node, 8 is coming in and it is splitting between 3. So 8 should be equals to I plus 3 plus 2. I is equals to 3 amps. Any question? Okay, we'll move to the next one. Now let's look at the voltage law, which is really, really important. And I want you to follow the method that I'm using. In some books, there are different methods, and even in your lecture notes, they are in different places, you have different ways. So we'll stick to one method so that we are sure that we don't go wrong. So voltage, Kirchhoff voltage law says when you go around a closed path, go around a loop, algebraic sum of the voltages are equals to 0. So, so you start at a point and you are going around the loop. So you can go around any direction. Okay, so you don't know the direction of current at this point. You haven't learned to find it, so don't worry about it. You can either go this way or this way around the loop. So I'm going to go this way, and you are adding the voltages. So I told you some are supplying voltage, some are some are supplying energy, some are consuming energy. So algebraic sum means you need to consider whether it is a source or a consuming part. The easiest way to do that is you look at whether the current is entering the negative side or a positive side. So this current is entering the negative side of the voltage source. So we have a negative V1. And when it is going to a resistor is always consuming. So resistor is always consuming means current is going to the positive side. So when the current is going to positive side, you add it. So V2. And then here V3 also adding. Why we are adding? The current is going into the positive side. Whenever the current is going into positive, we are adding. When the current is going into the negative side, we are minusing it. So again, here we are minusing V4 and we are going to positive side. So we are plusing V5 and we are coming back to the start point. So loop is completed. So we are saying this is equals to 0. So algebraic sum of the voltages equals to 0 means this. Does that make sense? Okay. Don't worry about this one. Okay, so I want you to do this and find me V1, please. Apply the Kirchhoff voltage law, KVL, and find me the V1, please. Start at a point, any point, and going along the path. Should we add or minus 12? Negative 12 or positive 12? Please talk. Otherwise, I feel like I'm talking to no one. Positive or negative?
Is it negative?
It is negative. Why? The current is going into the negative 12. So negative 12. Then it is going to what? Positive or negative V1?
Positive.
Positive V1 and going to positive 2 and coming to the start point, and this is equals to 0. So you can find V1, which is, what is V1? So minus 10 plus V1 is equals to 0. So V1 is 10 volts. Agree?
Yep.
Okay. Okay, so I want you to do this one now and find me V1. So you start at the point, you're going any direction, it doesn't matter. So negative 20 and positive V1, positive 2, negative 4, positive 8 is equals to 0. So you can find V1. Can you find me V1 and tell me what you get?
It'd be 14, wouldn't it?
Yes, it is. It is 14. Do you all get 14?
Yep.
I am telling you always it's okay to go any direction. So can you do that in this direction and make sure that you get the 14? Check whether you get the 14. Now I'm going in the opposite direction. So then in that case, what do we have now? 8 is what?
Negative.
Negative 8, because it is going to the negative side. So then you have a positive 4. Am I right? then you have a -2, then you have a -V, and then you're going to the +20. So it is equals to 0. So still, if you simplify this, you still will get V is equals to 14. Agree? So it doesn't matter which direction you are considering to apply the voltage law. Around a closed loop, the algebraic sum of the voltages are equals to 0. Makes sense?
Yep.
Okay. Okay, I would like you to try this one, please. And we need to, okay, so first find me write an equation. Let's write an equation first. Start at a point. Let's do it together. We have negative VA, agree? Then we have positive V1. Then we have positive VB. Then we have positive V2. Then we have positive V3 is equals to 0. Am I right?
Yep.
This is not what they're asking us to do. They are asking us to find some equation for current. So what can you say about any resistor? So there's some voltage sources. So these are known numbers. It can be 10, 20, whatever it is. But resistor, whenever you have a resistor, you know a relationship between current, voltage, and resistance. How can I write V1 in terms of current and resistance? So these all are in series. So whatever the current going out is the same current throughout. It is the same current going out and coming back to the back here. So if I want to write V1 in terms of current and the resistance, how can I write V1? I times R1. Am I right? And in the same way, I can write V2 as I times R2, V3 as I times R3. So now you can substitute these ones here and you can simplify the equations and you can find I in terms of V and R. So what do you get? I'll give you few minutes. It's not electrical, it's maths. Just substitute the V1, V2, and V3 and make the I the subject and find me something for I in terms of VA, VB, and R1, R2, R3. What do we get?
I got I equals VA minus VB over R1 plus R2, R3.
Yes. Do you all get it? So V1 plus, if I take the V1 plus V2 plus V3, and then we have VB minus VA. So I just take this one to the end. So this is what we have. I just rearrange. This is equals to 0. So we can say this is IR1 plus IR2 plus IR3 plus, or else you can take this to the other side, which is VA minus VB. So common, I is common, so we can say R1 plus R2 plus R3 is equals to VA minus VB. So I is equals to VA minus VB over R1 plus R2 plus R3. Are we good? Any question? So you can simplify it like that. Okay. So I would like you to try this one. I think we are almost done the theory part. I think we don't have any other theory part. One more theory part, yes. So we have time to do a few questions. So can you try this one, please? Use KCL and KVL both to find current I1 and I2. So we need to find the current I1 and I2. So I1 is this one, I2 is this one. Okay, so we can use KCL and also we can use KVL. We'll do together, okay? Let's use KCL. KCL says whatever the current coming into a node is equals to whatever the current going out. So here, if you look at this node, what are the currents coming in? I just circle the arrows. So you can say the currents coming in are I1 and 2. Agree? And the current which is going out is I2. Is that right? Am I right? So this is one equation. Am I right? When applying the KCL, you can get this equation easily. Now let's do the KVL. To apply a KVL, we need to have a closed loop. So let's use this one here. You start at a point and you're going around the loop. So I'm starting at this point. So when I'm coming to here, it will be negative 20. So this is the application of KCL. Now we are doing the KVL. KCL, we get I1 plus 2 is equals to I2. So this is KCL. Now I'm applying the KVL. Starting at this point and we are going any loop, okay? So loop is a closed path and we are selecting any loop. So I'm going along this one. So we are going to a negative side of 20. So this is a negative 20 and we are going to the positive side of this one. So how do we know the voltage here? This voltage is equals to I1 times 5. Do you agree with that? Resistance is 5, the current is I. So instead of putting a V, unknown V, we can just say this is equals to plus 5I1. And we are going to the positive side of this one. So that will be plus 5I2. And coming back to the start point, and this is equals to 0. Agree? So we have another equation here, which is equals to negative 20 plus 5I1 plus 5I2 is equals to 0. This is applying the KVL to this node here. They're asking us to find the I1 and I2. Can we find I1 and I2 now? You have two simultaneous equations, two unknowns. We can solve the two equations and we can find I1 and I2. Do you guys agree with that? Have you done in maths solving simultaneous equations? So we can say this one is, we can divide all the terms by 5. So 4 plus I1 plus I2 is equals to 0. And I can substitute I2 from this one to this so that I can say negative 4 plus I1. Instead of I2, I'm going to write I1 plus 2 is equals to 0. So I can write negative 4 plus 2I1 plus 2 is equals to 0. So I1, 2I1 is equals to 2. So I1 is equals to 1 amp. So if you know the I1, you can substitute it in any equation and you can find the I2, which is equals to 1 plus 2, 3 amps. So I1 is 1 amp and I2 is 3 amps. Any question?
All good, thanks.
Okay, so we have done that. Okay, so we did. Okay, so we have one more theory part, which is very important again. Voltage division rule and current division rule. So voltage division rule we can apply when we have resistors in series. We know when the resistors are in parallel, voltage is the same. But when the resistors are in series, this voltage, and this voltage across 3 resistors will be different. So we are going to have an equation for finding this. And the current division rule is for the resistors which are in parallel, because we know in series resistors, same current is going through the resistors. But when the resistors are in parallel, current is splitting. So we should know how to find the current. So we are going to get 2 equations and we will be using it in question. So you can remember this one again. When the resistors are in parallel, voltage division rule says to find the voltage across this one, that will be R1 divided by R1 plus R2 times V. When to find the voltage across the R2, that will be R2 divided by R1 plus R2 times V. V is the total voltage which is at the source. So we can use these 2 equations to find the voltage across resistors. So we will do questions so you will get familiarized with these ones. So you can see, to find for R1, R1 divided by. To find for R2, R2 divided by R1 plus R2 times V. But okay. How can we find when this is only true? You can use this equation only when you have 2 resistors. But when you have 3 resistors, you can't do it. The thing is, you need to first make it to 2 resistors. So are these resistors are in parallel or series?
Yes, they're parallel.
They are parallel. They have the same voltage or different voltages? They are parallel, yes, that's true.
Same voltage.
Same voltage. So do we need to apply the voltage law here? We don't need to apply the voltage law. They're asking about the current, and this is actually, you don't have to do anything with the voltage law here. The voltage is the same. So we'll come back to this question after doing the current law. I think I have to swap that one. Okay, so current law says, current law is applied when the voltages are in parallel. So here you can, when the resistors are in parallel. So you can see these 2 resistors are in parallel. So this total current, I current, is coming into the node and it is dividing between the resistors. So how do we know how much of current is going through each resistors? So we can apply the current division rule. So to find the current going across the R1, current is acting like this. So current like to flow in the easiest path. When you have higher resistance, current like to go through the less resistance path. So resistance is like an obstacle. If you have a short circuit path, current is always going through the short circuited path. It's not going to take the trouble to go through a resistance. So current is opposite to the voltage. So when you have high resistance, current is less. When you have low resistance, current is high. So to find the current going through the resistor 1, that will be R2 divided by, to find for R1, that will be R2 divided by R1 plus R2 times I. To find the current going across the R2, that will be the opposite resistance divided by R1 plus R2. So voltage law is different. Voltage division was the same resistance. If I go back here, see, to find the voltage across R1, you divide R1 by R1 plus R2. But for the current law, you divide the opposite resistance because current is opposite. Like it's like to flow in the easier way. Voltage is proportional to the resistance. So it is R1, to find R1, it is R1 divided by. These rules, these equations won't be given to you. Why? These are basic knowledge, the basic that you need to know. So, is that make sense?
Yes, so far, Yupika, yep.
Okay, so now let's apply the voltage law and current law, current division rule, and we'll find the voltages across two resistors in series, applying the voltage division rule. So you can see this 40 volts are divided between R1 and R2. Voltage across the R1 is V1, voltage across the R2 is V2. If I want to find V1, voltage across the resistor 1, that should be, how do we find it? 15 divided by 15 plus 20 times the total voltage, which is 40. Agree?
Yep.
If I want to find V2, that will be 20 divided by 15 plus 20 times 40. You can see the only difference is this and this. To find across the 15, you divide 15 by the total times 40. To find across the 20, you divide 20 by 50 total, which is 15 plus 20 times V1. If you add these two together, what you should get?
You should get the total 40.
You should get 40. So if you find one, you can minus that number from 40 and you can find the other one even without applying the equation. So when you add the total, because the total voltage supplied is 40, so that is divided between two resistors in this proportion, depending on how much resistance it is. So you divide it between the two resistors. However, when you add them together, you still should have the total resistance which was at the source. Are we good?
Yep, I'm comfortable.
Okay, so would you like to try this? You can apply anything that we have learned so far. Let's use Kirchhoff voltage law, which says around a loop, you get algebraic sum of the voltages I equals to 0. So I'm going to go through, we are applying KVL to loop 1. When you apply KVL to loop 1, you start at a point, you go around, you can start at any point. So this will be negative 24, and I'm going to positive V1, and I'm going to negative V2. Coming back to the start point, this is equals to 0. So I have one equation. Applying this to loop 1. Now I'm applying KVL to loop 2. Start at a point. It's up to you which direction. I told you it doesn't matter which direction. So I'm going to the positive side of V2 and then going to the positive side of V3 and going to the positive side of 12. All are positive, doesn't matter. So still it is equals to 0. So this is my second equation. Am I right? Then if you apply the Kirchhoff voltage law for third loop, this one here, I start at this point and this is going to 10 positive and negative V3 is equals to 0. So V3 we can find as 10. So you have three equations. You can substitute V3 to this and you can find V2, which is equals to 12 minus 10, which is 2 volts. And now you can substitute that one here and we can find V1, which is equals to 24 plus V2, which is 26 volts. So we found V1, V2, and V3. So there, it's very simple. When you learn the theory, the basics, electrical is very easy. But as I told you, we are going to complex numbers, we are going to calculus, we go to all that. But if you understand from the beginning, the basics, you won't go wrong. It's very easy. Are we good?
Yep, that was good.
Okay. So yeah, I want you to do one question with the dependent source. So did you identify there is a dependent source in this one? So you have two current sources. This is an independent current source and this is a dependent current source. This current is depending on V naught. Agree?
Yep.
What is V naught? V naught is the current times the resistance here. Am I right? The current coming out, going in this loop is I naught. So I can say V naught is equals to I naught times 4. Am I right?
Mm-hmm.
And here I can say the voltage here is 2 times 4 I naught. And we can say 8 I naught. Am I right?
Gotcha.
Okay, now you can apply anything. If you apply KCL to this node, KCL to this node here, what are the currents coming in? All the currents are coming in. Look at the arrows. We may get negative later on, but look at the arrows that we have. All are coming into the node. So I can say I naught plus 10 plus 8 I naught is equals to 0. Am I right? So we can say I naught is equals to negative 10 over 9 amps. Is that right?
Yep.
In the question, they're asking us to find the V naught. So what is V naught? V naught is 8 times I naught. So V naught is 8 times whatever you found for I naught. So you put that in the calculator and you can find V naught. So that's just applying maths, just solving maths. So whenever you have independent source, that's how you do that. Are we good? So these questions are in the tutorial as well. We will do it. But if you understood this, you can try all the questions in the tutorial now.
Yeah, we have a list of questions to do, Upika.
Yes, let me show you. So I think, yes, I'll give you time for you to try. And these are from the tutorial. I'll show you where to find the tutorial. Are you guys happy to do more questions? Or is it too much? So these are from the tutorial anyway we are doing on Wednesday and you can try, but as we have 30 minutes, would you like to do this or are you okay with this ones?
I'd like to work on them myself.
Okay.
Sort of.
Yeah, so that's okay. I'll just summarize the things and I'll show you where to find the questions, okay? The Brina and Vivian, are you all, do you like to try the questions? We can try if you want.
I'm following, but honestly, my brain is fried. So
yeah, so you try.
Yeah, I'm not doing anything myself, but I'm following what you're saying.
Okay. Yeah, I'll let you guys try, but I will summarize everything that we have done. So this is what all that we have studied today. We learn about